everyone, Mr. Thomas Wick here with lesson 1-16. Today we're going to focus on multiplying radicals. In the previous lessons you guys have been adding and subtracting them. I think that you're going to find that multiplying can be a little bit less frustrating than the adding and subtracting because you don't have to worry about getting your like bases before you do your operation. We can multiply through and then worry about simplifying at the end. Alright, let's jump right in. As we said, we're going to be multiplying radicals in this lesson, which means our learning target is going to be that I can multiply radicals. So to multiply radicals, we have to multiply the radicand by the radicand. And remember, the radicand is that number that's underneath the radical. And then we multiply the coefficient by the coefficient. The coefficient's that number in front of the square root symbol. So let's go ahead and look at an example. Example number 1 is 4 square roots of 3 times 5 square roots of 8. So what I'm going to do first is just multiply the radicand, 3 times 8, and that's going to give me 24. I'm going to keep that under a square root symbol. And then I'm going to do my coefficients, 4 times 5, and that's going to give me 20. So just to recap there, the 24 came from 3 times 8, my two radicands. And my 20 came from 4 times 5, my two coefficients. Now, we do want to go ahead and simplify this answer, so I'm just going to rewrite my answer over here, 20 square roots of 24. Now, if we're looking at what goes into this, we're looking for a perfect square that does go into 24. And if you remember, 4 times 6 is 24, and 4 is a perfect square, 2 times 2. 6 is going to stay underneath. So we're going to pull out of the pair of 2's, we're going to pull one of those 2's out and multiply the coefficient. So that's going to give us 40. And then that's going to leave us with the 6 underneath the radicand. And that is just simplifying the answer that we got from the multiplication. And we have our final answer. It is important when we are doing these multiplication problems that you know after multiplying that we don't forget to simplify our final answer. So this was a pretty easy example. Let's go ahead and look at another example. Now you will notice in your notes that it has 5 square roots of 5x plus the square root of 3y squared, but it would be silly to have an addition problem in our examples when we're trying to do multiplication. So go ahead and change that plus sign into the multiplication sign like I have right here. I'll give you guys a second to do that. Alright, now, we're still going to multiply the radicand by the radicand. So we're going to have 5x times 3y squared. Alright, 5 times 3 is 15. We only have the 1x, and then we have the y squared. So that's going to go under our radical, and be our radicand. And then we need to multiply the coefficients. We have a 5 here. Now notice there's no number in front here. So just like when we have an x with no constant or coefficient in front of it, we're going to have a 1 in front of it, just like we would put in front of an x that was all by itself. So this is really 5 times 1. And 5 times 1 is going to give us 5. Now we do want to make sure we simplify. Now 15 doesn't have any perfect squares that come out of it. If we do our prime factorization, it's going to be 5 times 3. Neither one of those can break down into perfect squares. So that 15 is going to stay underneath. Our x is going to have to stay underneath. But that y squared is the same thing as y times y. So we can go ahead and pull that y out. So our final answer is going to be 5y square roots of 15x. Alright, let's do one more example. We're going to have a binomial times a binomial, except this time we're going to have radicals. We're still going to follow the exact same rules that we would when we were multiplying our polynomials though. We want to distribute this first term to both terms in the second binomial. So we're going to start out square root of 3 times the square root of 3. We're going to multiply underneath the radicand. 3 times 3 is 9. And these both will have a coefficient of 1. And 1 times 1 is 1. And so since 1 times anything is just itself, I'm going to leave the 1 off of here to save a little ink. Alright, now I need to do the square root of 3 times the square root of 4x squared. Now just like if this was a binomial times a binomial when we were dealing with polynomials, I'm going to add whatever I get from this term to what I get when I multiply all the previous terms. So I'm taking the square root of 3 times the square root of 4x squared. So 3 times 4 is going to give me 12, and I just have the x squared. Again, the coefficient is 1 times 1, so I don't need anything out front there. Now, I'm going to need to take my second term, and I'm going to need to multiply it through my second binomial. So I'm going to put another addition sign because I have to add all these on. We have the square root of 2x times the square root of 3. 2x times 3 is going to give me 6x. And again, my coefficients are 1, so I don't have anything in front. And now I have to multiply the second term by the second term in my second binomial. So a 2 times a 2 times a 4 is going to give us 8. And an x times an x squared, remember this has an exponent of 1. And our properties of exponents say that when we multiply like bases, we add the exponents, so 1 plus 2. And that's going to give me x cubed. Now the last thing I want to do is I want to simplify this and see if I have any like terms that I can add together. So the square root of 9 is just going to be plain old 3, because 3 times 3 is 9. If I'm looking at the next term, there's a perfect square of 4 in there, which means I can pull the 2 out, and that's going to leave me 3 underneath, because remember 4 times 3 is 12, and that 4 can be factored into 2 times 2. Also, that x squared is x times x, so I can pull that x out as well and stick that x outside the radical. Plus, now 6 doesn't have a prime factor as I can't simplify 6 at all. I can't pull anything out from there, and I can't pull anything out from the x. So that's going to be still the square root of 6x. And then at the end, 4 times 2 is 8, so I can pull out the square root of 4, which is 2. And I'm also going to be able to pull out an x from the x cubed, because x cubed is x times x times x, so I have the square there that I can take the square root of and pull out the 1x from. And that's going to leave me underneath 2x. Now I do want to check to see if any of these have the same base, or if they have the same number under the radicand. They don't, so I'm not going to be able to simplify this any further. So this is going to give me my final answer. I am going to rewrite this a little bit just to make it a little bit cleaner looking. We do like to have our constants at the end and our variables at the front. So I'm going to just go ahead and rewrite it, and I'm going to have my final answer here. Alright, go ahead and begin work on the practice, and if you have any questions, feel free to let us know. See you next time.